Welcome to Kelvin Smith Library's Generative AI and Information Literacy Day. My name is Jen Green. I'm the Associate University Librarian for Access, Research, and Engagement Services. And Roger Zender, who is right here, is our AUL for Curation and Curation Services. And we've worked together with many, many people, presenters, panelists, staff at KSL, Media Vision, Bon Appetit, to coordinate this event today. So it's great that it's finally here. It's great to see you all in person and online. We have a number of participants joining us online today. So I'm glad that you're all here, and we're thrilled to have you join us for what we're expecting to be an engaging and thought-provoking series of discussions today. Before we dive into today's agenda, I want to take a moment to highlight the diverse expertise of our presenters and panelists today. While they may not claim to be experts in artificial intelligence, they bring a wealth of knowledge and experience from their respective fields as librarians, technologists, instructors, and faculty members. Their unique perspectives will enrich our understanding of how generative AI intersects with information literacy and hopefully provide valuable insights and foster meaningful conversations today. I think today's event is a testament to the collaborative spirit that drives innovation and progress at KSL and at CWRU. And so we've invited colleagues from across the campus and disciplines so that we can explore together the implications of AI in our work and our lives, and to collectively navigate and openly discuss challenges and opportunities that are in front of us and ahead of us. Throughout the day, I'd encourage you all to be active participants, ask questions, share your ideas, share your thoughts. Your engagement is crucial to the success of this event. It is my pleasure and privilege to introduce to you our keynote speaker, Youngjin Yu, who is the Elizabeth M. and William C. Treuhaft Professor in Entrepreneurship and Professor of Information Systems at the Department of Design and Innovation at the Weatherhead School of Management here at Case. This is where he also serves as Associate Dean of Research, an Association of Information Systems Fellow. He is also a WBS Distinguished Research Environment Professor at Warwick Business School in the UK. He is a faculty co-director of XLab at Case Western Reserve University, and he has worked as the innovation architect at the University Hospitals in Cleveland, overseeing the digital transformation efforts at one of the largest teaching hospital systems in the country. He studies digital innovation and has published at leading academic journals such as MIS Quarterly, Information Systems Research, Organization Science, the Journal of AIS, Information in the Organization and the Communications of the ACM, and the Academy of Management Journal. The title of Professor Yu's presentation today is Matter, Science, Bits, and Vectors, Cognitive Emancipation and Material Limitation in the Era of AI. And I'm very happy to have him here to speak with us today, so please join me in welcoming Professor Youngjin Yu.
All right, good morning. Thank you for having me, Jen and Roger. So this is a talk I did. It's an evolving talk. I've been working on it. So I first developed it when I was visiting Rome, and there was a event organized, sponsored by Cisco, and a colleague who invited me to speak at that event started talking about, these computers started with the bits, now they are vectors, and there's something changed. And that made me, curious about that transition. So I decided to go down the rabbit hole of studying some of these key papers of computer science. I don't claim that I fully understand all the complex math behind, but I was trying to, with the help of ChatGPT, understand what the hell was going on with these papers. And then I gave a couple presentations, and you might have noticed that the subtitle has changed to reflect some of the evolving thoughts that I have. So I'd like to start with I don't know if I click here. Okay. So I'm going to show you a video. This is a classic video. Some of you who are doing cognitive science or psychology may recognize. This is, Hider and Simil animation. It runs about 90 seconds. I'm gonna let you watch and what you think, what thoughts come to your mind. All right. So it's obvious that it creates some emotion. Some of you laugh at the end. So they ran this experiment throughout different cultures. They found that people across different culture all have similar different emotional reaction. They can create a story out of this very abstract animation of abstract geometric forms. I saw this video first time when I visited AI lab at USC. And that lab was funded by US Navy. And their job was trying to make a computer to understand this animation in a way that humans do. And then I asked them why you want to do that. And they said it's because when a soldier is monitoring radar with blinking blips of white dots, they have to be able to differentiate friends and foes. And that interpretation is very, very critical, and it is only human can do. That interpretation of that abstract movements of abstract objects, but we create meaning. People could tell that's evasive move, that's aggressive move, as you saw on that video. So some of you may have heard an episode on NPR, This American Life, on June 23rd last year. And the story is about Microsoft researchers who were given the opportunity to see ChatGPT before anybody else in the world. And they were very skeptical, but over time, they were completely just blown away. And they wrote a paper about it. So given that one of the tests that they came up with, the guy named Peter Lee claimed to be the one who actually came up with the test, was that given that LLM cannot actually see an image, he decided in the middle of the night, because he couldn't go to sleep because of the shock he had with ChatGPT, he went to ChatGPT and said, draw me a unicorn. Using a software program called TIX. It's a latex vector graphic software. And then it generated a software code, and then it ran it, and the image was this. And he was just blown away. Now, clearly, ChatGPT has an ability to visualize the text and then create the text, the code to generate certain image that it wants to create. Now, what was really amazing to me, though, is that if I don't tell you that this is a unicorn, people may not recognize it as a unicorn. This is an abstract assembly of abstract geometric forms again. But once I tell you the story, you cannot not see a unicorn here, because now we are interpreting this image as a unicorn. The point is that it is a human, unique human ability to draw meanings out of these abstract symbols, and the machine is able to invoke that image deliberately by assembling these geometric forms. And to me, this is quite remarkable. So I said, okay, here's what I'm going to do. I'm going to reverse the whole thing. So I said, what if I reproduce the original Himmel hider and Simmel video animation using Python code, and then give the Python code to the computer LLM and ask LLM to write a story. So I had a monumental challenge of writing Python code to do that. And with the help of a Claude, I was able to write a very, very crude code. And I hope that I will be able to collaborate with some brilliant software developer actually who could build almost replicate real animation. But I only spent like 3 hours. So here's what I was able to do in 3 hours. I have not done programming over the last 15 years. So, and then I uploaded the code to Claude, and this is what Claude reproduced. In a world of geometric beings, Triangle lived a solitary life in the house of shapes. One day, curiosity drove Triangle to venture outside, where it encountered the lively duo of Little Triangle and Circle. You can read the rest, but it is quite amazing that what was impossible merely 12 years ago by the smartest people who are working on cutting-edge AI, funded by U.S. Navy, could not do, I was able to do in a matter of 3 hours with no Python programming background to speak of, and just an idea. I was having, to be honest, like a shot of single malt after dinner, and I was thinking about this talk and how can I make it a little bit more interesting, and I was able to do. So let me dive into the main part of how do I do this talk. So throughout human history, we humans have struggled with the limitation of our material existence. As Homo sapiens, we are blessed with amazing, remarkable software called brain. It is a highly efficient, imaginative, symbolic processing, and generative computational machine. This symbolic knowledge has allowed us to transcend the boundaries of our immediate physical reality and explore the vast realms of abstract thoughts and creativity. However, we are also cursed with our feeble body, subject to the constraints and frailties of the material world. We are not strongest, fastest, and the most resilient species on Earth. So throughout history, we constantly sought ways to overcome our material constraints, to extend our reach, and amplify our impact beyond the limitation of our physical bodily forms. So this tension between the symbolic and the material, between the boundless potential of our mind and the harsh reality of our bodies, has been the central theme that occupies the history of civilization. From the debate between the Plato and Aristotle, the realist and the constructionist, and the materialist and the idealist, we see this dialectic tension between this symbolic idea and the material constraint occupies a central place in our attempt to make sense of our civilization and how we can make it better. So in our myth and religion, we find the echo of this eternal struggle. The story of Lost Paradise, for example, a place of material abundance. The land where honey and milk flow is a recurring theme across all different cultures. The first Chinese emperor, Qin Shi Huang, was looking for the medicine of mortality, hoping to escape the bonds of the physical death. In the modern era, the fascination of non-material digital assets with a zero marginal cost led some economists to call for an abundant economy. Other technologists believe that we will reach the moment of singularity when we can finally upload our consciousness to machines, overcoming the material constraints of our body. This is like a brief history of modern digital economy. With this myth and aspiration set aside, we can all agree that the human civilization was a direct outcome of our collective accomplishments of overcoming our material limitation we find here and now with our own bodies. And I observed two key strategies that we have developed. The first one is domestication of the material world. So we are using our imaginative power. Humans learn to domesticate the material world around us. We shape stone, wood, and metal into tools and machines that could amplify our physical strength and to extend our reach. From the earlier stone axes to spears and wheels, levers and steam engines, we were building new kind of tools over time. The second and more important, profound strategy that we have discovered is that we discovered the power of symbolic, abstract, disembodied abstractions. So through the development of language system or mathematics and music notation, we are able to manipulate the world in an abstract terms. These symbolic tools allow us to communicate complex ideas in simple knowledge token across time and space, preserve these over generation so that we can build models and theories of the world that could guide us, our action, to accumulate and transmit knowledge across generations. This is the essence of what we do at universities in a way. So in essence, the use of symbolic abstraction allowed for a kind of disembodiment of knowledge from its immediate material context, we're here, but abstract ideas encoded in language or other symbolic systems or knowledge tokens could take on a life of its own, independent of any particular physical instantiation. This embodiment of knowledge and invention of various knowledge tokens was a crucial step in developing culture, science, and technology as it allows us to create and transmit complex ideas and practice over time and space. So the combination of material tools and symbolic abstraction allowed us to create various forms of machines. So when you actually think about any kind of machines, that those machines are combination of these two elements, the materials and then symbolic knowledge. And that those inventions of machines drove the development of human civilization and our history. By creating new machines that embody new abstract knowledge in new material forms, humans have been able to harness new sources of energy that we were not able to use before. This in turn, the ability to harness new types of energy transforms the nature of work itself. And exploring different combinations of different forms of matter with a symbolic knowledge, which leads to new combination of form, function, and matter, is the essence of our design actions that are crucial in any technology development. So how does technology development through this design affect work? Here, I turn to the work of James Sussman. He is an anthropologist at Oxford. His recent book, Work, is a really interesting book to read. And he argues that work involves the transfer or application of energy to change a given situation. He's drawing from the classic work of French mathematician Gaspard Gustave Coriolis, I guess. Sussman notes that the work describes the force needed to be applied to move an object. It's a physical definition of work, moving physical object from one place to another. That is the definition, classic definition of work. He further notes that all living beings are critically depending on transferring or inorganic matter into energy source to keep us alive. And expanding this idea further, Sutsuma makes an observation that the evolutionary development of organic beings, human or any other living beings, is directly related to the expansion of their ability to transfer more inorganic energy into the means of survival. Over the course of evolution, we have evolved into complex, more energy-hungry, hard-working, in his word, life form. We consume more energy to survive. Our beings evolve into that being. And much of it goes into our brain. And he shows the size of the brain growing as we figure out how to conserve our physical energy to get things done. That was the main thesis of his work. Therefore, if new technology changes how we use and apply energy or allows us to use different energy to change the condition, it has an implication for work. Thus, the creation of new machines has been the key to major economic social revolution throughout the history, from the agricultural revolution to industrial age and modern digital age. So the creation of new machines involve what I would call hermeneutic translation, which is the movement between symbolic disembodied there, or global there, internet, for example, to the material embodied here. So we're dealing with digital or virtual audience there. What they get is actually the materialization of disembodied bits being transmitted through the internet, reenacted in a physical form through the beams out of their screen, which hits their neuron, their eyes, and create this sensation of seeing and hearing someone actually talking. So this is what we are trying to understand. The symbolic knowledge involves disembodied representation that is out there. The material condition is what we're dealing with here and now. So the rest of the talk, I will be traced very briefly the historical evolution of hermeneutic translation and the machines that is involved. But I will emphasize the transition from the digital era to what I call generative era. And that's and how that transition from digital computers from a generative machine is what, in essence, what we're dealing with now. So the first wave is the agricultural age. So essentially here, the source of energy before this was our human body. Agricultural revolution happened because we learned how to use tools, we learned how to control water, and we learned how to control animals. So that injected massive amount of new energy to cultivate the land, massively increasing the productivity. The Industrial Revolution is directly related to our ability to harness thermodynamic energy from the fossil fuel. And that allowed us to build new machines. New machine allowed us to build, control even more the energy, some thermodynamic energy, which led us to build even bigger machines. So this created this virtuous cycle of making things bigger and better. And that was pretty much the story that Alfred Chandler and others have documented through the history. The third wave is what I would call digital revolution. It started in mid-20th century. And it comes with primary form is a reduction of uncertainty, entropy. Movement of the bits is a primary way of creating new potential opportunities that we have. And I'm going to get to more details a little later. But here, this led to the rise of information economy or digital economy and knowledge workers, and whose primary task involved the manipulation and analysis of digital symbols and tokens. The scholars like Zuboff and Castell have done major work in understanding this era. So now we are entering into the fourth era, and I propose to call it generative revolution. And this is not just about generative AI. This is far more profound and transformational. And this is why I believe that what we are seeing now is not some sort of hype. There is hype, but it is more than the hype that we need to pay close attention to it. So let's unpack the key here is the transition from the IT or digital revolution to the generative revolution involves the transformation of digital computers from inorganic and syntactic machine to organic and semantic machines. So I'm going to take you through this. So emergence of organic and semantic machines. What do I mean by inorganic machine? Inorganic machine I'm referring to is von Neumann computing architecture. So the modern computer is based on every computer we have, except quantum, is based on von Neumann's basic idea, which is, some would argue, I would agree, Alan Turing's idea. And it was that we could load a set of instructions and a set of data to the central processing unit, and then it'll produce output. And as long as you have the same input and output, same input and instructions, you should get exactly the same output. Now, why do I call it inorganic machine? So I'm borrowing this idea from the work of Bergson and Deleuze on life and intelligence. So for them, inorganic matter are characterized by repetition or near repetition, where separated elements are rendered capable of returning to previous state or directly anticipating state to come. These repetitions, past and the future, are already contained within the present. Observing their present configuration in enough detail provides us with the capacity to understand their future arrangement. That's inorganic by definition by these two philosophers. Organic life, on the other hand, is a complex fold of chemical and the physical that reveals something not given within them, something new, emergence. Life that exists within matter, that seeks to extend matter beyond itself and its present forms, is not the origin of virtue, but rather one of its modes of actualization, the potentiality of matter itself, insofar as matter is the material of life as well as non-life. So some of you who are following the newer version of assemblage theory in physics and chemistry, this is exactly the idea that Deleuze has proposed. So inorganic machine, I'm literally borrowing their definition, are machines characterized by repetition or near repetition whose future state can be predicted within enough observation. Organic machines are a complex fold of hardware, software, models, and data connected through procrastinated and temporary binding in runtime that reveals something not given within them, something new emergence. So what are the examples? Amazon homepage never gives you the same page twice by design. You go in now, go back in 5 minutes later, it will give you something because you know you were there and didn't buy anything. So it learned that it needs to do something different. The Facebook and Twitter timeline algorithms are deliberately designed to not give you the same content twice. Google search results, I just did my name twice, 6 months apart, completely different. More than 100,000 new pages were linked to, I don't have any idea why that is the case. Apple iOS ecosystem. Over 2 million apps, they are being updated, deleted, purged, added, revised every single day. Note to iPhone are exactly the same. So from the moment they leave Shenzhen factory, comes to your home, come to your hands, and then you begin using it, and they evolve into different being. This is the idea that Simondon had in his work. So this idea, and of course, we had ChatGPT, which is like ultimate hallucination machine of organic machine, right? Another transition that we need to pay attention to is the transition from syntactic machine to semantic machine. Along with von Neumann computing architecture, another pillar of modern computing technology is called Shannon's digital communication theory. So in his master thesis at MIT, which 1944, I believe, and which later published as a book in 1948, a mathematical theory of communication, Shannon invented bits. Think about that, inventing bits as your master thesis. And he basically foresaw the world of internet coming. Basically says any representation, any type of data can be reduced to ones and zeros. But here's what he wrote here. The fundamental problem of communication is that of reproducing at one point, either exactly or approximately, a message is selected at another point, right? Without loss. That's essentially what he's saying. Frequently, however, the message have meaning. That is, they refer to or are correlated according to some system with a certain physical or conceptual entities. These semantic aspects of communication are irrelevant to the engineering problem. What he's essentially saying, at some other point he said, as long as you don't care about meaning, we can communicate perfectly. Right? So what he was building and what we had was what we call syntactic communication tool. It doesn't know what it's communicating, but it is perfectly communicating its syntactic content. So we know words have different meaning in different context and how it is being used. So let's take a look. How does it do? So this is a slide deck that I borrowed from Mike Rojas, one of our colleagues. So you have this two-dimensional grid with a bunch of different tokens, and each token represents different object in the world. And we want to place Apple in this grid. Okay, where should I put it here? A, C, B, D. So it could be either A because it's round, or it could be C because it's a fruit. So we put there, and the vector space of Apple is going to be 5 and 5 because it is both fruit and round. In a way, this is what we do when we vectorize data and we do the word embedding. And you could do it more with more dimensions. And current LLMs have about 6,000 dimensions. Can you imagine that, right? It all happens with the following evolution. So it all begins with this particular paper, 2012, AlexNet. It was the first time the neural net could understand image using embedding. Then disentanglement came automatically using high-dimensional vectorization. It begins to unravel underlying dimensions without human intervention. Variational autoencoder begin creating continuous vector space. Generative adversarial network demonstrated that we can actually generate a high-quality image. Word2Vec was done by Google people, that we could do the word vectorization and produce static semantic meaning. It is a static. Then attention mechanism allow us to do the dynamic mechanism, and then transformer made it possible to do it in massive scale. Then Elmo, without using transformer, was the first pre-trained large language model that could be packaged and given out to other people. Then the rest is history. BERT took 340 million parameters, and then GPT-1, 170 million, GPT-2, 1.5 billion, GPT-3, 175 billion parameters. Discovering scaling law suggested that as you increase the number of parameters, which is number of layers and number of vectors and dimensions, approximately, this is how we make these machines more intelligent. And then we have this ChatGPT. We broke all the record. Within 2 months, they have 100 million users. So we are now living with these generative machines that is both semantic and organic. That's my argument. So what does this all mean? Well, we have a separation of representation and semantics. It used to be the representation human actually carry semantics. And now we have a machine that could actually manipulate this what we called polysemantic neurons to stimulate itself, and then creating this high-dimensional vector space and a semantic object, which is context agnostic. This context agnostic object can be combined through simple mathematical algebraic manipulation, producing meaningful representations. Now, I'm very careful here not to say they are creating meaning or they are understanding meaning. They are creating meaningful representations. People can recognize, oh, it looks like it is understanding me. In fact, it may not. We have no idea. But it does create meaningful representation. So generative machines with their organic and semantic capacity are transforming our relationships with work, tools, and humans with potentiality, profound implication for economy and society. And I would argue that generative AI, frontier generative AI, should be considered as disembodied semantic space, as a collective knowledge common, that we pull our creative energy into in the disembodied form, so that we can all harness it together. Now, that would require a very different form of organization and governance structure. Vipin and I, Chowdhury, the CS department chair, and Shannon French were on a panel together yesterday, and we all agreed that we need true open source large language model that is controlled by true open foundation, not by some folks. To represent, this is the finest collective disembodied knowledge of that represent our current humanity, which then we could build on top of it. Anybody can leverage it. The Holly Harden is a pop artist who has done something very interesting, and what she did was she created this voice model that crowdsourced many millions of voice samples from singing, talking, narration, in order to create very nuanced, contextual understanding of the texture of a voice, human voice, and then use it as a way of creating a very creative music album. And I think it is an example of what we could, her album is called the Proto. And I think it is something that we may want to see more of in this, instead of like leveraging Scarlett Johansson's voice to create ChatGPT's voice. This is the right way of doing some of the work that we are trying to do. And obviously, we need new energy. It is not just electricity, although it does require a lot of electricity. And it shouldn't come as a surprise, given how cognitive evolution always, based on the work that Suchman did, always required the transformation and access to new source of energy. And that usually went to the growth of our own embodied brain. Now it is growing disembodied brain, collective brain, I would argue. And we are also feeding into it. That sounds very much like a matrix, but that is what really is happening here. The new organizational forms, I would conclude, as a management scholar, I cannot not talk about it. So when you think about it, agricultural revolution, the source of energy was kinetic energy. Organizing form was tribal and state nation system. The financial instrument that we had was barter system for the most part. During the Industrial Revolution, we were using thermodynamic energy. We developed hierarchical coordination and control systems. We still teach that, unfortunately, in business school. And major financial instruments were securitization of capital, separation of ownership and management that led to the explosive growth of modern capitalism. Digital revolution deals with an anthropic energy as a source of energy. Network organization and platform is what we have seen. And financial derivatives have become a major source of financial instrument. Now we are entering into this generative revolution, and we still do not know what is the new form of organizing forms, what are the appropriate forms of financial instruments to fund these activities. We still do not know. So from management standpoint, these are one of the most frontier issues that we need to wrestle with. And I think it is for all of us to embrace. These are some of the projections of power. And so we are continuing this evolutionary journey of our cognitive capability, reconfiguring our relationship with tools and works and knowledge tokens in different ways. But the question is, where are we going with this journey? And I think the destination is, in a way, we are in a control seat. We should try to understand what this technology is doing to us, and how we should better use this technology to shape the world for a better place to live. Thank you.
Thank you so much.
Do you have time to get questions?
We have time to take questions. We've given us a lot to think about for the day, and I'm sure there are questions. Would anybody like to start with the first question? Oh, we've got one back there.
Thank you very much. That was a very nice way to look from, what is it, up from the top of the mountain. Think about where we are and what is our responsibility. So I'm at the Mandel School, and in collaboration with engineering, we started a certificate in data science for social impact. And the motivation was seeing how algorithms and in general data and all these new data technologies and administrative data are being used to inform decision making in child welfare, in homelessness services and the like, and realizing that even if one is not a data scientist, having a knowledge to inform those algorithms is really important. So having that semantics, being comfortable in the languages of AI and machine learning, causal modeling is important for social workers to have. And I loved that graph where you synthesize everything. I was wondering if we could have a column there for human-tech interactions, which is what I'm trying to learn and at the same time share with our students. But then that seems to be kind of escaping as generative AI takes place, right? We become less and less able to interact with that technology. And that, again, we're seeing that even if originally these algorithms were trying to address discrimination bias, they're not quite there yet, right? So having that additional column would be really fantastic. And having your thoughts about how human-tech interaction can ultimately lead to a better society, which was your ending words. That would be helpful. Thank you.
Right. Yeah. So I have a couple thoughts. Thank you for the question. So first one is, I think at the end, data is the fuel. This as knowledge token that we create is what goes into this AIs, right? I call it like a creative energy, but it is essentially the data as a knowledge token that goes in. Data is not inevitable. So I'm reading a book written by my colleague Yanis Kallinikos and Christina Alaimo. It's a very profound book. I strongly encourage you to read the book. The title of the book is called Data Rules. And what they're arguing essentially is that data is not inevitable, meaning that it is a consequence of the decisions human made in creating that the artifacts, right? What we are not paying enough attention to is that early stage or upstream work of defining data, the very act of defining what part of the real world will be represented in the data is exercise of power, a most insidious exercise of power, I would argue, because nobody actually pay attention to. It is reduced to the exercise of low-ranked data scientists, data engineers, who actually do not understand the power and meaning of the activities that they do by declaring that this is the only field that we need to capture. I vividly remember when I was working with, inner city minority groups in Philadelphia. We are doing open data initiative back in mid 2015 or so. And 13, and they raised hands, and one of them said, look, you guys government are, releasing all the open data, but the data that you have actually does not represent my life. And there's no means to express my life, my needs, my current condition in any form or shape. So I will never forget that moment, right? It was the most boring part of any system development activity is like defining the data dictionary, and that's what they were talking about. And that level of sensitivity and the importance of social consequences of those actions, I think is extremely important. In terms of the technology human interaction, I think I agree with you. I think that's an important element that I should add. Essentially, I think what we are learning is that people are having a hard time dealing with this in organic and semantic machine, because we are almost every other tools we have are inorganic. It does what I ask it to do, and in an expected way. When it seems like its own opinion and its own mind, we anthropomorphize that machine. We are not dealing with them very well as a tool. So we still struggle how exactly deal with these things, right? Some people absolutely just refuse. My wife refuses to talk to Siri because she doesn't like to talk to machine. Or other people think like a Siri is my lover, like my friends, which also is not very healthy relationship. So, and we need to define the new type of relationship interaction pattern. I think that's a very rich area of research, again, that human-computer interaction is well as established field. But I think the new modality of interaction, I think it is important. Unfortunately, oftentimes economists reduces it to two dimensions: augmentation and automation, and that there's far more nuanced and complicated way of thinking about our interactions. But that's kind of like where we stand in econ business world at the moment. So, Mark.
If we can take a couple more questions. Any other questions?
First, sorry, I've been sick. Thank you very much for your comments. I had something that you said was that as we move from inorganic to organic, we go from predictability, we go from I tell it what to do and it does it, to something that creates these meaningful representations instead, something that's unpredictable. So much of academic research has been built on the idea of replicability, the concept that I do something, I explain it to somebody else, they can also do it. So what are the impacts for those of us who are trying to enter into this field, understanding that I can't explain things to people the same ways, that I can't do something that is replicable anymore? How do we start to measure, like, what does science look like here if it's no longer replicable? Is it something closer to art now, where I can teach you how to do brush strokes, but every painting is different? It just feels like we're changing the landscape of what we think research looks like,
right.
Potentially.
Yeah, I think we can be really philosophical here. I would take the view of Deleuze, which is like nothing repeats itself ever. So in the purest sense, there is no such a thing as a pure replication. Now, what we do is we're looking at probabilistic trends and estimates. So, I am different than yesterday. My body physically, it's different. Many of my cells yesterday died, and I have full of new cells. So I think what we're dealing with when we replicate, it's a probabilistic reproducibility of similar patterns that we observed in the past in a similar context, and repeatedly so. And so that's what the statistics does. So I think, in these generative machines, they are not random. It is probabilistic machines. So they have a tendency of doing certain things more likely than in certain way if you do certain prompts. So, and then with this kind of like, way of using overly saturated data, they tend to converge really, really quickly. So, the current version of LLMs increasingly is less interesting and more boring, rather quickly, unless you know how to prompt very well. So I think that's my reaction. The idea of pure exact replication is not the spirit of replication. Replication always a probabilistic sort of, reproduction in a way. So
We have time for one more question, which is right over here.
Hi, I'm delighted to get the management financial perspective. The rivalry between proprietary and open source is all important. Everything I've contributed over the last 54 years is open source pretty much. And I work for open source foundations. But the expense of creating a generative AI frontier foundation models is so mind-boggling
Right.
that even the great open source organizations like Mistral in France are thinking they're going to have to close it.
Right.
Can you do the management financial forecast of the it was your last column
Yeah,
and there
yeah.
was a question mark, so
Right.
please answer.
Yeah, I mean, I think that's a great question. I think it's $1 trillion question. I think, people like Sam Altman is trying to do it through this like a hybrid structure where they say on one hand, we are governed by non-for-profit organization and all of that. Whether we trust that or not, I think, and you're right, asking the right question, right? The initial fixed cost investment of building these machines are so high with energy and the chips and human labor that goes in. So yeah, I wish I have an answer for that, but maybe there is a clever financial instrument that every one of us will have an option to exercise in the future when this thing does take place, right? So maybe it is some form of citizen investment fund or something. I have no clue. Maybe some of my colleagues in financial engineering will come up with an instrument. So thank you.
Well, thank you so much, Jungden, for your excellent talk. And this is giving us, like I said, a lot to think about. And hopefully we can reach out to you if you have other questions. Let's give them a